Go. 11.5. Seems like it's been a while since we've done a new lesson, hasn't it? So here we go. We're going to talk about, we're actually not talking about triangle. Well, we could talk about triangles. Yeah, this is not hard. Basically, you're learning one thing. That's about it. So that's a nice change of pace, isn't it? Just learning one thing. But we're going to apply it to different figures. So let's do this. Let's make a rectangle. I want to show you why this thing works first before just showing you what it is. Actually, let's do this. Let's copy and paste this. Now, watch. I copied and pasted it, hit the Shift key, and I made it a little, well, if I could click on this thing, there it goes. Made it a little bit smaller. So tell me, what do you think is true about these two figures? They're similar to each other. Very good. All right, we had a whole chapter about things being similar, didn't we? So it's a rectangle, and let's say this is 5, and this is 9. All right. So if they're similar to each other, let's do it the other way around. Sorry. You could actually keep those there if you don't want to erase it. Let's go this. Let's say this is 5 and this is 9. All right. So if we know that they're similar to each other, I'll put a little squiggle right there. So we know they're similar to each other. So if we know they're similar to each other, tell me something about the ratios. This would be, let's say this is 2 to 1. Okay, the big one to the small one is 2 to 1. So what would this side right here be? It'd be 10. Okay, or 2 times 5, right? Or let's say we didn't know it was twice as big. It might be 3 times, 4 times, 5 times as big. So it would be what? 5 times, let's say, x. Okay, you can use x. I think they use k for constant. Let's use k. Is that all right? I know constant starts with C, but I just say K for constant. I don't know why they use K, but they use K for a constant, okay, to make a constant. So is that all right, saying 5K? Does that make sense to you? So we don't know, in fact, that it's twice as big. It could be 2.5 times as big, right? So this side right here could be 2.5 times as big as the 5. It could be 3 times the 5. It could be 4 times the 5, whatever. We don't know, do we? So I'm going to make it a K. So what do you think I'll make this one down here? Make it 9K. Now what I want you to do is see this. We're talking area, right? This whole chapter is about area, so we're going to talk about area again. Let's do this. Let's first of all, well, let me just show you. Let's say this was twice as big as this. I would venture to guess that your first thought might be, okay, if this side is twice as big as this, if the sides were twice as big as this, then what's probably true about the area? You would think, wouldn't you? Okay, but let's watch. So let's just do that. What would the area of the small one be? I'll put AS for area of the small one. It'd be 5 times 9, which is what? 45.
Please excuse the interruption.
Right? So the area of this would be 45, wouldn't it? What about the area of this one? The area of the big one. I'll say B for big. Yes, we do. What's wrong? 5 times 9? It's 45, isn't it? It's 6 to 13. 6 to 13. I was asking you the question. If this area, or if the lengths were twice as big as this length right here, would the area be twice as big? And I know, but listen, but you didn't listen to everything I said, okay? I'm like, you would think, right? I said you would think that would be true, wouldn't you? But let's look at it. So what do you think that indicates? That that's not necessarily true, right? Okay, so that's what I was getting at. Okay, but it's good that you saw. It's good that you're looking at it to see that. Hey, wait a minute. Okay, it's not going to be twice as big. So tell you what. Let's make this even easier. Let's forget this K stuff. All right, let's just forget that. Let's say it actually was twice as big. All right, so let's say the lengths were twice as big. So if this is 5, what's this? 10. Okay, it's twice as big. All right. If this length is 5, this length is 10. If this was 9, what would this be right here? It'd be 18, wouldn't it? Okay. So let's take a look at the areas. What would the area of this little one be? The area of the small one. It would be what? 45. Because 4 times 9, or 5 times 9 is 45, right? What would this be? The area of the big one is 180. Is that twice as big as this? No, it's not. Okay? It's actually 4 times as big, isn't it? So how did we get to 4 times as big? Well, let's do another one. Watch this. Let's make this even bigger. Oops, I don't want to get rid of that rectangle. Let's do this. Watch. Let's make it 3 times as big. Let's just go one more, okay? I just want you to see. So if it's twice as big, right? So if the lengths are, so 2 times, is that right? I don't know. I'm like real scattered on this. I'm not sure the best approach to do. I'm just winging it here. So if it's 2 times as, if the sides, right, if the sides are twice as big, what's true about the area? It's what? It's 4 times. Does that make sense? That x is times, right? 2 times, 4 times. Everybody see that? Okay. Let's make it 3 times as big. So what is this? This would be 15. What would this be? 27. So let me do that. What's 27 times 15? Nobody's doing it? I'll do it. 27 times 15. It's 405, isn't it? Whoops. That's 405. Is it 6 times as much? How do you know? How can you tell how many times more this is than this? Oops, why did I do that? Divide. Very good. Take that 405 and divide it by what? 45. And that'll tell you how many more times. It's 9 times as big, isn't it?
Oh, do you square it?
Ah, there we go. Now we're getting into something. Okay, so now we're kind of seeing a little pattern developing, right? So look. So if the sides are 3 times as big, the area is not 3 times as big. It's what? It's 9 times as big. So take a wild guess. What if I made the sides 4 times as big? What do you think the area is going to be? It's going to be 16 times as big. So really, what are you doing to your ratio? Your ratio is 2 to 1, isn't it? Right here, if it was twice as big, your ratio is 2 to 1 for the sides. Would you agree? What would it be for the area then? It would be 4 to 1. You see that? So what if the ratio was k to 1? What's the of the sides? The ratio of the sides was k to 1. What would the ratio of the area be? K squared to 1. That's right. So I want you to read, there's a theorem. Theorem 11.1. It's on 802. Look at that. We're on the 5th section, and this is our first theorem. How about that? Isn't that crazy? So look at it. What's it say? It says if 2 polygons are similar, because we said these are similar, correct? It says their areas are proportional, right? So the area of this to this. So are proportional to the square of the scale factor between them. Do you hear that? So the area is proportional to the square of the scale factor. What was the scale factor on this first one? It was 2 to 1, wasn't it? So what's the proportion of the area of one to the other? If this is twice as big as this one in length, what's it going to be in area? It's going to be what? 4 times as big. Anybody paying attention? See, I should have never given you the problems you're going to do because now everybody's working on the homework. So everybody look up here. So look, if the area, or if the length is twice as big as this, then what's true about the area? It's 4 times as big. What if this was 10 times as big as this? The sides, the lengths of the sides were 10 times as big as this. Then the area would be what? 100 times as much. All right? Because what are you doing? You're multiplying this times this, right? This is twice as big. This is twice as big. So times 2 times 2. You follow me? So it's squaring it. Got it? So if it's 3 times as big, times 3 times 3, that's 3 squared. If it's 4 times as big, this times 4 times 4, it's 16 times as big. Make sense? All right. So that's basically what that thing says. So let's take a look at an example, and then we'll be finished, and then you can do your thing with the homework. One of what? One of the really hard ones? Haven't even done a really easy one yet. Let's take a look at this. All right, let's do this one. Let's do this one. let me pause this while I draw a picture. All right, now we've got our picture drawn. Let's see what they tell you. It says triangle JKL is similar to triangle PQR. So you know which ones go with what. All right, and it says the area of JKL, so the area of this one right here is 30 square inches. 30 square inches. It says find the area of PQR. So what is the area of this one? Put a question mark there. All right, so this is the kind of stuff that they're going to ask you to do. So what do we know? We know if we take the ratio of the scale, or if we take the scale factor. Okay, let's do the scale factor. JK, which now they've only marked one over here, so it's pretty obvious which one goes with what. But let's just make sure. This JK is that one, right? It goes with what? PQ. So the 12 and the 15 definitely go together, don't they? So let's do that. Let's go 12 over 15. In fact, let's make this a little easier for ourselves. Let's reduce this thing so we can find the actual scale factor. So what? 3 goes into both of those, 4/5. Did I do that right? Yep. So the scale factor is 4 to 5. What did our theorem that we just talked about say? It says if we take our scale factor, the square of the scale factor is going to equal the ratio between the two areas. You hear what I just said? If you square the scale factor, it's going to equal the ratio of the two areas. So what am I going to do with this? Square it and square that. And that's going to equal the ratio. Now what did we compare? We compared the smaller one to the larger one, correct? So what are we going to put over here? No. Because we want to compare it to the areas. This is the square of the scale factor. But it's... no. We want to set it up first, and we'll take care of the math. All right? So this is the square of the scale factor. What's going to equal? It's going to equal... No. Don't do 16 over 25. I'm not trying to figure this out yet. Remember, listen to what the thing says. Okay, I'll read it again. It says the areas are proportional. Okay, they kind of do it a little backwards than I'm doing. The area is proportional to the square of the scale factor. This right here is the square of the scale factor. What's it equal to? It's equal to the areas. Okay, so what am I going to put on top here? 30 over what? We'll just call it A for area. Is that all right? You could call it X. Doesn't matter. Doesn't make any difference at all. Now you can go ahead and figure out what your math is. But I wouldn't even go 16 over 25 right now. What would I do? I'd probably cross multiply, wouldn't you? So watch. 4 squared times A, because sometimes that number could be a real ugly number. I mean, it's 16, you know that, but I'll just do it like this. That's equal to what? 5 squared times what? 30. Divide by what? 4 squared. See, that you don't have to do a whole bunch of stuff in your calculator, do you? Right? It's not like you have to figure it all out and then just put it right here. So what is it? 25 times 30 divided by 16, and hopefully that gives you around 46.875. Is that right? Did you try that? Nobody's punching them in? I'm not getting many response from you today. What's going on? Everybody's busy doing their homework. You should pay attention because you might learn some things that you might not get if you're not paying attention. So that's what you should get. Okay, it's inches, so it's square inches. So that's how you can find the area of this. So what did we do? We took the scale factor, we squared the scale factor, right, and set it equal to the same ratio of the areas, right? I compared the small side to the big side, I squared them, and that equals the small area to the big area. Does that make any sense at all? Okay.
Do you always have to do it in that order?
You don't have to do it in that order. No, it doesn't have to be in that order. You just have to make sure that that the two sides are compared. But watch, if you compare the small one to the large one, the area has to be small to the large. I could have gone the other way though. I could have compared the large side to the small side. I would have had to compare the large area to the small area. Okay, so I could have gone 15 squared over 12 squared, and that would equal what? A over 30.
So the area of PQR now equals 40.
That's right. So this area right here is now 46.875. Exactly. That's that area right there. Does that make sense?
Yes.
All right. So what you do, again, real quick, take the scale factor, right? I like to reduce it. Just makes your math a little bit easier so I don't have to go 12 squared over 15 squared, okay? So I just reduced it 4 over 5, but then you got to make sure you square your scale factor. Square the sides. Okay, well, you gotta, that's why, remember up here I said, hey, if these sides are twice as big as these sides, the area is 4 times as big. Well, that's the only thing you have to remember on this lesson, so remember it, okay? So it's really the only thing you have to remember. It's the only thing about this lesson that you have to memorize. So make sure that you square the scale factor. Read that theorem over and over to you. It says that the areas are proportional to the square of the scale factor. You don't square the area. No, it's already been squared, okay? So you only square the scale factor, and you set it up equal proportional to the areas. Get it? Okay. The rest are the same. You could have all kinds of different figures. It doesn't have to be a triangle. It doesn't have to be a rectangle. It could be all kinds of figures. But what's true about both figures, though? They have to be what? Similar to each other. Okay? So that's the only time this works is if they're similar to each other. Sorry, it seems like I was a little disjointed on this lesson, but I think you got it in the end, didn't you? Just trying to figure out how to start on this. I kind of like how I did this instead of how they did it. I was going to go with that K thing, and I kind of like how I did it better.
What if they like jumble it up differently though?
Yeah, it'll be fun.
Like a huge number. So what if you go like, if your fraction would be like 35 over 20?
Well, that's why I'm putting all it into the calculator.
Like going
I'm not doing a little bit, putting it in, doing a little bit over here, putting it in. I'm gonna
number 2A. Can you do one?
2A,
Yeah.
like the example
They
thing.
give you the two areas and
Okay.
the other one they explain it.
I'm not gonna draw the pictures. Is that all right? So let's go. Let's compare the sides. What would it be? It'd be x to 6, right? But it would be what? What do we do to the scale factor? The scale factor would be x to 6, but what do? We square it, don't we? Okay, and that equals the area, right, of the small one, because that's the small one, compared to the area of the big one, 72. Everybody with me? And now you just do your math. Cross multiply. So it actually, tell you what, I'm not even going to cross multiply. What can you do? Just get rid of that 6 squared. So I just multiply by 6 squared. That's a lot easier, isn't it?
Oh, so you
Because x squared's on top already, isn't it?
both squared, so you just do 35.
Oh, I get
Right?
it.
So you just multiply by 6 squared because you're dividing and you get rid of it. And then you got to do what to it? You got to get rid of that square, so you do what? Square root. So what I would do all that in my calculator in one shot. Okay? Don't put all those numbers, don't square and put them in there. Now, wait to the very end, put it all in one shot, and then you're good to go.
Do you do a problem with the side or when the sides have a decimal?
A decimal? Well, what would be the difference? Like number 8, like 1b at the top. Like 13.5, the area is 13.5? Is that what you're saying? Find one that has that. I mean, it wouldn't be any different. I mean, just because it's a decimal doesn't mean the process changed at all.
Like 8 because
Like number 8?
It's 2 A's the answer 5.
You don't. Listen to what I've been saying. You got to listen to what I'm saying. You don't reduce it. You keep it squared. Look, did I ever make 6 squared 36 one time? No, I didn't. I kept it 6 squared. What if that wasn't a 6? What if it was 2.78? Then I don't care what that actual number is, 2.78 squared. I keep it there, and then I throw it in the calculator.
Yeah.
All right? Because it's a decimal, it's not going to make it any more difficult for you. All right? Does that make any sense at all?
Yes.
So, for instance, I'll do number 8. Watch. 28 over 15.4, right? But what do you do with the sides? You square them. And what's that going to equal then? If I go 28 to 15.4, I got to go 500 to, we'll call it x. Right? Cross multiply. But don't figure out what 15.4 is and stick it in here. Don't do that. I'm telling you. I've said that several times already today, haven't I? Yeah, I think it's much better to just keep it squared and then throw it in your calculator at the very end. Okay? So what would it be? It would be, let's see, it'd be 28 squared x equals 15.4 squared times 500. Divide by 28 squared, and then chuck that in your calculator. See what I mean?
I got 51 points.
So you only have to do your calculator one time. I mean, you don't have to. I mean, but for some people,
Do you get an odd number.
You could do
like a decimal
this.
point, like I just put X on one side.
If you put this on the other side, you got to put this on over here, but you got to switch things around. You got to take the bottom, put it on the top, take the top, put it on the bottom. I think it's just as easy just to cross multiply. But yeah, I mean, if you can figure that out in your head, you know, how to arrange X by itself, it doesn't really matter how you do it. Whatever's good for you. Anything else?
So what was that answer though? 151.25.
Yes, yes, it was. 151.25, yes.
And was 2.
I'm not doing any
that
more
one that
for
we
you.
did 2A, was that answer 5?
2A.
Yeah.
Which one was that? This thing right here?
Yeah.
I don't know. What page was that on? I don't remember where that was.
803.
2A. What'd you say it was?
5.
5. Yes, it was 5.
You said 6. I did it last night and I was super excited.
6 is 81. 10 is... Well, if you find X, it's 10. And then 12, if you find X, it's 6. Because on those last sections, they say find the scale factor of the blue one to the green one. That shouldn't be that hard, right? Because once you find X, you can just do the scale factors. No big deal. All right, that's pretty easy. Really, only one thing to really know as far as squaring that stuff. And then the rest of it's pretty good. All right, so what did I say? 6 to 13, right? Numbers 6 to 13. Section 11.5. And we're going to take a quiz tomorrow, right?
Yeah.
And that's going to be section 11.3 and 11.4. All right, there's the stuff. See you tomorrow.